Hello student, I hope your preparation is going good. There is a new series of thermodynamic. I have already completed the 4 part of a thermodynamic previous year PSU questions. So I will continue the 5th chapter of this series. So going ahead with the further discussion, we can also try to close all this question which is coming in thermodynamic related to the PSU exam, related to your specific state examination. All those important question which is coming in any of the examination we will solving over there. So I'll try to complete this playlist as soon as possible so that you have sufficient time to practice these questions. And if you need any further information related to this or any other requirement related to other subject, you can freely mention in comment box. So let's begin with the videos. So the first question of thermodynamic, it's a part of like first law of thermodynamic and second law of thermodynamic. Few of the questions are pending in that series. After that we will start with the entropy. So the first question which you need to like solve, most of the question over here are numerical, so do not worry about these things. These are the basic question, and these question are definitely come from any of the examination which they have mentioned over here. This question coming from the ESC 2018, and in this question they have mentioned like just try out to find a keyword what they have tried to confuse you. In that question, a thermodynamic cycle is composed of 4 processes. They have mentioned there are 4 processes over there, and the heat added and work done in each process are as follows. So they have given 4 processes and given the heat transfer and work done, and these are in joule. The unit of both the terms are in joule. So the first process 1 to 2, they have mentioned like 0 joule of heat transfer, and in work done there are 50 joule of work done by the gas. Similarly for the process 2 to 3, having 50 joule of heat transfer with from the gas, and 0 joule of work done they have mentioned for the process 2 to 3. Similarly for the process 3 to 4, having 0 joule of heat transfer and 20 joule of work done on the gas. They have mentioned on the gas, by the gas, from the gas. Similarly for the process 4 to 1, having 80 joule of energy with the to the gas, they have mentioned point to be to the gas, and from the total work done for the process 4 to 1 with the 0 joule of energy. So they have mentioned these 4 cycle and mentioned from the gas, to the gas, by the gas, on the gas. Whatever system is done, like whatever work is done on the system, always negative. By the system, like someone is working on you, having a negative impact, like someone is pressing on you, like you are continuously going to compress it. These are the negative work done by the system. And similarly for the work is done someone else, like you are doing some external work, so that particular time you are giving your energy to the someone else, that in that case you will giving the positive work. Similarly over here as well, for the heat transfer exactly same thing, heat rejected and heat gain by the system. Heat rejected by the system, heat gain, they have a particular signs over there. They have mentioned you can just put these sign convention and try to solve the total thermal efficiency of the cycle. Just remember they have given a 4 option. So going ahead with the solution, so basically they have mentioned heat rejected in a question. They have mentioned heat rejected was 50%, if you remember. Just a minute. They have heat rejected for the system was 50 from the gas. That's why they have considered a heat rejected negative signs. And for the from that particular perspective, heat rejected Q2 is 50, and similarly heat added 80 joule. They have calculated from here itself, here from the process 4 to 1. And if you observe that thermal efficiency is 1 minus Q2 by Q1, also 1 minus T2 by T1, these are the theoretical efficiency. But in each case, whenever the heat rejected, heat added is given, you can go with this formula. And once you put all these value Q2 and Q1 over here, you will get 37.5% efficiency of thermal efficiency of that particular cycle of 4 cycle which they have mentioned over here. So I hope these questions are clear now. So moving ahead with the next question. These questions are coming BHEL GT examination, engineering training examination. So in this question they have mentioned these are the heat engine type of question, and these are questions most frequently asked in any of the examinations related to most of the PSU have asked. Even for the gate examination is also asked same type of question. So a heat engine receives 1 kilowatt of heat transfer at 1200 Kelvin. Remember the parameter, there are heat engine, 1 kilowatt of heat transfer, temperature was 1200 Kelvin, gives out 600 watt as work around 600 watt. with the rest as heat transfer to ambient temperature. The remaining heat will be transferred at the ambient temperature of 300 Kelvin. There are two temperature and two heat terms, like there are 1 kilowatt, 600 watt, 1200 Kelvin and 300 Kelvin, trying to find out the unit along with the what was the term is given. And after that they will given the second law of efficiency of engine, like you need to calculate the efficiency of the engine based on the second law. There are four options. Remember that, try to plot the cycles whatever they have given in a question, and try to give the whatever data they will provide, try to draw in a cycle itself, so that you can clear what you need to do it. Remember that the heat engine received 1 kilowatt of heat transfer with the 1200 they have given temperature with respect to your heat transfer, gives out 600 of energy will be out as a work with the temperature of ambient 300 Kelvin. If you plot the same thing over here, then you will find that the total heat supplied was 1 kilowatt, which they have mentioned over there, and also W unit is 600 watt, and total heat supplied at the time of 1 kilowatt having temperature 1200 and lower temperature which is 300 as a ambient temperature. I have already explained in a question itself. And if you calculate the second law of efficiency, if you observe over here, then the second law of efficiency is consist of a actual efficiency divided by maximum efficiency. Actual efficiencies come from the with respect to W terms, W and QS, and for the maximum efficiency is calculated based on the theoretical T. So here W and Q is played a role of calculating the actual efficiency, and maximum efficiency from the theoretical perspective in terms of temperature. So going ahead to calculate what was the actual, they have mentioned over here. For the actual you need to calculate the W net and QS, and W net they have already provided in a question. 600 watt is there for the W net, and for the heat supplied is 1 kilowatt, that is you need to convert into watt, so 1000 watt, and if you solve that you will get the 0.6 as the actual efficiency. To calculate the maximum efficiency they have given this formula. These are the standard formula, 1 minus TL by TH, and if you solve that, TL was the lower temperature, that is 300 as an ambient temperature, and TH was highest temperature, that is 1200 where the heat is supplied. If you solve these terms, you will get maximum efficiency was 0.75, and if you put these two terms over here, then second law efficiency of engine will be 0.6 divided by 0.75, you will get 80% of a second law of efficiency of an engine. So I hope this question is also clear. These two questions are most frequently asked questions based on the second law of thermodynamics. Going ahead with the next question, engine operate between, these question is also asked in 2 to 3 examination, and try to look out the like year, which examination, which year they have asked. And these question is asked in 2 years, like BPSC and UKPSC AE examination, both are the AE paper. So these questions also plays an important role while selecting the questions. So an engine operate between the temperature limit 900 Kelvin and T2, and the other engine operate between T2 and 400 Kelvin. For the both engine to be equally efficient, T2 should be equal to. Try to read question at least 2 times so that you need to clear, because I have already practiced a lots of question. I have got the scenario in a single attempt. So there are two engine. One engine is operate between 900 and T2, and second engine operate between T2 and 400. Both the engine have equal efficiency, they have mentioned. If you remember that there are two cases in second law of thermodynamic, I'll just brief about that. In each case, like first case we will consider as the equal efficiency. For the second case we will consider as a both the work done of the engine are same. In such a case we will derive with the two formula, and for the equal efficient energy you need to calculate T2 having under root of T1 and T3. These are the formula which is you need to remember. So if you put the T1 as the 900 Kelvin and T3 is the 400 Kelvin, and if you remember these, like when the efficiency are equal in such a case, then you need to remember these formula, like these are the specific case of this equation. So if the efficiency are equal, then you need to remember T2 equal to T1 into T3 of square root of that particular term. So T1 is 900 and T3 is 400. If you put these two answers, you will get T2 as a 600 Kelvin as a final temperature of these two engine of a main efficiency when these efficiencies are equal. So I hope this question is also clear. And going ahead with the next question, this question is asked in Vizag Steel 2017 MT examination, and same question is also asked in Vizag 2020 examination. And also this question is asked about the OPSC AE 2015 paper, and these are the like most type of repetitive questions. So in this question they have asked like one reversible heat engine, like you remember that heat engine they have mentioned, operate between two temperature like first 1600 and T2 Kelvin, and another reversible heat engine operate between T2 and 400 Kelvin. If both engine having same heat input and output, then the temperature T2 is equal to. If you remember, these questions are almost same with the previous question, and just making the frame in wordings, like changing the framing of the words, and you need to calculate the temperature of T2. Remember that they have given a temperature 1600 of the first engine with the T2, and another reversible heat engine operate between T2 and 400, and you need to calculate the T2. If you remember that the same formula which I have explained the previous case, you need to just remember that formula, like T2 equal to T1 and T3, and if you put T1 and T3 over here, you will get 1600 and 400, and you will get T2 as 800. And they have already explained the relation over the cycle T2 and T1, like first T1 and T2 and then T2 and T3. They have tried to correlate the efficiency of both the engine and finding the relation of T2 with respect to T1 and T3 and put the formula and get the final answers. Try to remember these shortcut. It is very useful at the time of examination, because examination consists of lots of time to try to solving the calculation and deriving the equation. So better you need to remember all these equations. So going ahead with the next question, this question is asked about HPCL along with the UK PSC examinations, and these are the like theoretical question you need to solve within a 10 seconds. So the second law of thermodynamic is also known as, I think you all are aware of that. Most of the most of the student having doubt related to the options, try to memorize these types of question, because if you remember that, you can quickly solve this question less than 2 to 3 seconds. If you not, then it's very difficult. And if you do not, try to write somewhere else, so that at the time of revision you need to remember it. So in this question they have mentioned the second law of thermodynamic, also known as law of entropy or qualitative law of thermodynamic. Quantitative known as the first law of thermodynamic, qualitative law of known as second law of thermodynamic. They have also mentioned like the first law of thermodynamic is also known as law of energy or quantitative law of thermodynamic, which I have already explained earlier. Qualitative going with the second law, quantitative going with the first law of thermodynamic. Internal energy deals with the first law of energy, first law of thermodynamic, and second law of thermodynamic deals with the entropy. Just remember these two terms. Going ahead with the next question, this is also the theoretical question, and you need to like memorize these types of question. The statement like the efficiency of all reversible heat engine operating between the same temperature level is same as is known as. They have mentioned like the efficiency of all the reversible heat engine operating between the same temperature level is same as, like they have mentioned what was the theorem, which theorem you consider it. So if you remember that the efficiency of all the reversible heat engine operating between the same temperature, these are the corollary of a Carnot theorem. If you remember that, these are the right option of this equation. If you do not, try to memorize these types of theoretical question. We do not have any other option related to this like theoretical question. Try to memorize so that you can solve this question quickly. So as I have already explained, these are the like Carnot theorem, and that's why they have mentioned in option A as the right option. So going ahead with the next question. So the coefficient of performance COP of heat pump, remember that the word heat pump, working on reversible Carnot cycle is 6. COP of heat pump given as a 6. If this machine work as a refrigerator, try to reverse the cycle with work input as 10 kilowatt, then the refrigerant effect will be. If you remember the second law of thermodynamics, they have derived the formula, and for the COP as well as a heat pump, and the COP for the refrigerator. If you know the relation between them, then you can solve this question, because this question is asked in a ESE 2018. And if you do not have idea, then definitely you will mark a wrong answer in between them. I am sure, because most of the student every time have a confusion with this formula, that's why they have put the wrong answer. And wrong answer is also available in the same option, so make sure that you have remember these types of questions. So in this question which they have mentioned like COP of heat pump given as a 1 of COP of refrigerator, these are the standard formula. Remember that, like HP 1 plus R. If you remember these types of equation, COP of heat pump equal to 1 plus COP of refrigerator. And if you put like COP of refrigerator is given, you need to calculate it. COP of heat pump is given as 6, and if you minus then COP of refrigerator, you will calculate as a 5. And if you calculate the COP of refrigerator as a 5, you need to calculate the refrigerant effect. So then COP of refrigerator is equal to refrigerant effect divided by work input. As you already calculated the COP of refrigerant, you just put it over here, and work input is already given as a 10. Then you will get the final answer as COP, like refrigerant of that particular refrigerator having 50 kilowatt of input. So these are also important questions related to the COP. So I have almost covered all the type of question for the first law of thermodynamic and second law of thermodynamic of all these two chapters. So next chapter is related to entropy. So in entropy, I mostly cover with the more question which is frequently asked in PSU examination. For the entropy, basically they will ask a theoretical along with the few of the numerical type of question. Very few, but most of the question in entropy are theoretical question. Few questions related to numerical, what was the entropy? There are basically 3 formula in that type of question they will ask. Otherwise, you can consider every time they will ask you the theoretical question. So going ahead with the first question, this question is asked in TNPC and UK PSC examination. So the first question was, for a reversible engine cycle, the Clausius inequality says that there are 4 options. Before reading the entropy question, you need to remember what was the Clausius inequality equation. If you remember that, then you can solve this question. Otherwise, it's not applicable to you. So there are 3 conditions for the Clausius inequality. dq by t when equal to 0, then this type of cycle has a reversible cycle engine. If dq by t is less than 0, in such a case the cycle was irreversible cycle engine. If dq by t is greater than 0, then this type of cycle is considered as an impossible cycle. These are the 3 conditions. Based on the condition, you need to mark this option as a C, which they have already mentioned in questions. So going ahead with the next question, the value of dq by t for an irreversible process. If you remember that the previous question, dq by t for irreversible process, if you remember over here, for dq by t should be less than 0. So they have directly given this question, and you need to mark this question. So always consider as a less than 0, that is option C as the right option. They have also mentioned the option over solution over here. If you do not have idea, then you just read it out over here. So going ahead with the next question, these are the important question which is come in ESE examination, and level of the question is little bit high as compared to the normal one. So try to be like focus on this question. So in this question, an ideal gas is flowing through an insulated pipe at the rate of 3 kilojoule per second. The mass flow rate of flow of gas having 3 kilojoule per second, and there are 10% pressure drop. They have mentioned the pressure drop was 10% from inlet to the exit of the pipe. The value of R is 0.287 kilojoule per kg Kelvin, remember the unit, and T0 was 300 Kelvin, that is temperature of the ambient. So the rate of energy loss for the pressure drop due to the friction will be nearly, you need to calculate the what was the energy loss. Remember that what they have mentioned, like there are the gas which is flowing in a pipe with the rate of 3 kilojoule per second, and there are 10% drop in a pressure from inlet to exit, and value of R is 0.287 kilojoule per kg Kelvin and ambient temperature of 300 Kelvin. You need to calculate the rate of energy loss for the pressure drop due to the friction. They have given the 4 options. So before solving this question, try to get the what was the reason and how you can approach these types of question, because if you do not have idea, do not solve, because take a time unnecessary. So entropy generation, before that you need to remember what is the formula for the entropy generation. So basically entropy generation is mr delta p divided by p1, and if you remember that all data they have already provided in a question. M already given in a 3 kilojoule per second, 3 kg per second, sorry, and R value they have already given 0.287 kilojoule per kg. All the unit they have provided in kilojoule per kg Kelvin. Similarly for the pressure drop, they have given as a 10% in a pressure drop, and initial with respect to initial they have mentioned. So there are 10%, P2 minus P1 they have given as a 10%, and if you put this formula, the P1 and P1 is going to be cancelled, and if you solve, you will get that the like entropy generation is 0.086 kilowatt per Kelvin, because all these data we will put in kilojoule per kg Kelvin. So rate of energy loss for the pressure drop due to the friction is I, irreversibility, is equal to T into delta S. Delta S is a system generated. What was the entropy for the generation of that particular universe? So I equal to T0 delta S, and T0 they have already given the ambient temperature 300, and entropy generation is 0.0861, which you have calculated over here. And if you put all these data over here, you will get 26 kilowatt as a final answer of entropy generation due to the loss of pressure. That is, the option C is the right answer for this question. So I hope this question is clear. If you have any doubt, still you can freely mention in comment box. I'll try to clear at that time as well. So the next question, if you discuss these things in your like vibas and other examination interview, definitely your interview will get appreciated to you. So the next question, this question is asked in OPSC civil services examination. So a heat engine, they have mentioned a heat engine, transfer 15 kilojoule of heat to a thermal reservoir at a temperature of 300 Kelvin. The change in entropy of the reservoir in the process is, they have given the heat engine transfer 15 kilojoule of heat from the thermal reservoir as a 300 Kelvin. You need to calculate the change in entropy of the reservoir. If you remember that the formula of entropy, delta S equal to Q by T. They have already given the value of Q, they have already given a value of T. You need to put the Q in terms of joule, because all the data in terms of joule need to calculate based on the unit requirement. So if you put Q value in joules and T value in temperature in Kelvin, so you will get as a 15,000 divided by 300, you will get the 50 kilojoule, 50 joule per Kelvin for the entropy of reservoir. And if you they get that, option B is the right option for these questions. So I hope this question is also clear. Going ahead with the next question, they have mentioned this question is asked in TN PSC examination, and this question is said about if T refers to the temperature and S refers to the heat, then for a process from state 1 to state 2, heat transfer in a reversible process is given by. Remember the word reversible process, and they have a particular state from 1 to 2 they have given, and these processes are reversible process. You need to calculate the what was the heat process. From this here we need to calculate the heat transfer. So they have given a temperature and entropy, and if you remember that delta S equal to dq by T for the reversible process, to calculate the maximum heat transfer, the T0, and if you remember that dq equal to T into delta S, and T0 is the ambient temperature multiplied with the delta S. Delta S you can written as S2 minus S1. Same thing they will put over here, and if you check that, the option A is the right option for these types of questions. These are the theoretical and formula based questions. You need to just remember the formula. So going ahead with the next question, and this question is asked in UPRV UNL examination, and this type of question is most important question because they have asked in almost every examination. Last year GATE has also asked these types of question. In last year and 2 years back they have also asked a similarly question, only change in the data itself. So in this question, stir works applied to a liquid in insulating chamber increases its temperature from T1 to T2. Like one chamber is there and they are insulated and they are supplied liquid with the temperature increases from T1 to T2. The change in entropy of universe, you need to calculate the entropy change of universe, where they have given a Cp is the specific heat of liquid. They have given 4 options. If you remember the condition, that type of, if you have already solved this type of question, then you have idea how you can approach these questions. But for your shortcut, I'll just explain you. The delta of like entropy of universe is equal to entropy of a system plus entropy of surrounding, if you remember this formula. So you have a like one system, and this system having consist of a stir which is providing the work over here. If you remember that these are the work which is done on the system, and these work and these beaker are insulated outside, there is no heat transfer. So delta Q is term in terms of Q equal to 0, we need to put it. So and consider the surrounding as outside, because we will consider system in the insulated tank. So for the system, if you remember these formula, Cp equal to ln of T2 by T1. For the surrounding, they haven't transferred any heat, so surrounding term is going to be 0. Then the universe is equal to system plus surrounding. You need to put this term as a 0, and delta of universe is equal to delta of system. So if you consider delta of universe is equal to system, because there is no heat transfer from the surrounding, then final answer for the universe is delta of the system and Cp ln of T2 by T1, which is answer D for these types of questions. So I hope this question is also clear, and I request like everyone, you need to remember these types of formula because these questions are frequently asked in every examination. So I have request to everyone, try to watch these videos at least 1 to 2 times more, so that you need to remember all these question, at least formula for your mindset. So in this question they have asked, this question is also asked in UKPSC examination, and in this question mostly deals with the theoretical type of things. So the main cause of irreversibility, you know very well the formula of irreversibility, I equal to T0 into delta S, which I have already explained you earlier, where T is the ambient temperature and delta S is a change in entropy of the noise. So they have mentioned that the main cause of irreversibility, the first option was mechanical and fluid friction. This is also right, because the irreversibility is caused due to the mechanical and fluid friction. Due to this, heat is generated. Unrestricted expansion, this is also cause of irreversibility. Heat transfer with the finite temperature difference, if these two are right, then definitely this is also heat transfer with the finite temperature difference. Due to this is also tends to increase in irreversibility. So if all the three is right, then option D is the right option for these types of questions. So I hope this video are helpful and related to your PSU examination of complete thermodynamic. I have completed till entropy. The remaining 2 chapters are still pending. I'll try to close as soon as possible. And if you have any type of doubt related to this, try to do mention in comment box. I'll try to resolve as much as soon as possible. And if you think this video is helpful with respect to your preparation, then try to share with your friends and subscribe this channel. And I hope your preparation is also doing well at the end. Thanks for watching.